Test 1, 2, 3. This is going. This is going. Let's get music. A little loud, probably. That's probably okay. Test 1, 2, 3. Let's get my chat up. Okay. Let's do 1242. How long is it? Whatever. Hours 15. Should be perfect. How are the levels? Probably good. Test 1, 2, 3. I feel like this needs to be louder. Is that gain, maybe? How's that? 1, 2, 3. Yeah, I think that's 1, 2, 3. Maybe that's good. I don't know. Okay. Black Slex. Black Slex and password. Oof, that is not easy to read. Shit. If I just go to Firefox, does it remember? It must remember, yeah. All I care about is my heat map. That's the only thing I care about. Oh, 2 hours, 30 minutes. All right, well then I'll probably give up 15 minutes early because I gotta go at 3 EST. Blackslex is designing a login system for Geen Dev and discovered that most users use weak passwords. To resolve this issue, pose the following conditions dependent on two variables k and x for all passwords. Each password has a string s for length n, satisfying these properties. S uses only the first k lowercase letters. For every pair of indices where j minus I is divisible by x, letters s, I, and sj are different. Find the smallest integer n that no valid string of length n exists. Interesting. Okay. That's kind of interesting. Wait, did I choose like a weird corporate sponsored thing? Maybe not, I don't know. String s of length n satisfying these properties. Okay, well it's just gonna be, I mean you could just have a bunch of A's and then a bunch of B's, right? So it's gonna be or x. So the first x things are gonna be, if you had x as 2, then index 0 and 1 are gonna be A, and then index 2 and 3 are gonna be B. So it's just going to be that times that plus 1. Right? That should, I mean, that's going to work with all these test cases at least. It's going to be something like that, and given that empirically that's the right answer, 376, I think I'm going to go with that. Black slicks and showering. I think the contest is still going on, so it's somewhat realistic that this takes a while. After his IMO medalist friend showered for 2 hours so that he doesn't have to shower again this week, Black Slicks will be late for his class. In order to go to class, let's take the crowded elevator to many floors in a certain order. Because he's a hacker, he can skip visiting up to 1 floor without the other people knowing. His time taken is the sum of absolute differences between consecutive floor numbers. Okay. And the minimum time taken given that he can skip up to 1 floor. Okay, well, you just try skipping every floor, right? I'm guessing there's like an array of floor numbers or something. Yeah, so we just get the answer, and then we take out for every floor, what is that going to be equivalent to? I think I don't even really need an array. I think I just straight up hack it. So I'll say AI is less than or equal to 100. I don't have to worry about int overflow. So sum is equal to 0. Int, what's the best you can do is going to be equal to start. I guess we'll say negative mod and make this an int. Sum minus mod. Okay. It's going to be a lot easier if I put it in an array. I'm just going to do that. Okay. So sum plus equals, I'm going to say if I is greater than 0, sum plus equals a at I minus 1, but the absolute value of that. Okay. And then I'll say int cur, let's get these down here. Cur is equal to 0. If I is greater than 0, then also the current, if you took this out, you would take out this difference. If I is less than n minus 1, you're also going to take out this difference too. And then MSF equals max MSF cur. Should definitely be MSF. Let's see, did I get this right? That's still in Q. 11, 2, 12, 8, 0, 8. What the fuck? So it's saying you could take this out. Oh, do I have to start at floor 0 though? Let's see. 4179. So let's say you start at floor 0, you go up by 4, then you go up to 7. No, if you just start at floor 4, then you go down to 3, or sorry, down to 1, that costed 3, that costed 6, that costed 2. So yeah, you can start at whatever floor. You can hack it to have started at another floor, I guess. $125. 25 seems too large, right? But I don't know. No, that makes sense. This costs 14. This costs 11. So I think my sum is not large enough. Let's see. 33 is the sum. 25 is the MSF. This must be really obvious. I don't... Sum is 0. Wait, so sum supposed to be 33? That doesn't sound right. This costs 11. This costs 14, so you're already up to 25. This costs 6, so you're up to 31. Yeah, that costs 2, you're up to 33. Okay. Oh, it's because you're taking this out, but you don't magically transport from 4 to 1. So I want to have if I is greater than 0 and I is less than n minus 1, then also cur minus equals abs a at I minus 1 minus a at I plus 1. Ah, okay. 11, 2, 12, perfect. In Q, I guess we'll just add another one to the queue, I don't know. This feels like good to know that this is what happens. Black selects and number theory. Right. This is a little unnerving. I mean, whatever. I guess that means I can't free up my like cognitive kind of memory of this. Not that that was costing very much, but I have to keep in the back of my mind like what the hell was going on here. Okay, black selects and number theory. We're too hard to start dreaming about numbers. Solve the following task from his dreams given an array 1 through n. You can choose an index I and an integer x, which is at least k, and set a at I equal to a at I mod x, where u mod v denotes the remainder of dividing u by v. Your goal is to make all elements in the array identical. Among all positive integers k, determine the maximum k for which there exists a finite sequence of the above operations that makes all array elements equal. X, which is at least k. Okay, so you could have like mod 3 and then mod 4. Does that matter at all? No, because if you had like 1 mod 3 and 3 mod 3, I don't think that it would ever make any difference. Right? Wouldn't it? I feel like it'd be close to just like the maximum number or something like that. Maybe not the maximum number, but... or the minimum number, something like that. The minimum number plus 1. That's almost what I'm seeing here. It must have to do with the minimum number, because if you had like mod 60, that's just, for anything below 60, not going to be relevant. So k needs to be at most. I mean, there's a world where it's like 2. No, there's not a world where it's 2, because you're looking for the maximum number. Right? Like if you had a bunch of 1,000,000, and then you said 1,000,000 mod 3, 1,000,000 mod 4, I think you'd always be able to manipulate it appropriately. Yeah, because you could just do mod that number minus 1, mod that number minus 2. So here, like if you did 4, you could just set everything to be 1 by like mod that minus 1. So if you did 5, or the answer is 6, that means you can set everything to be equal to 5 because you can't change this number. So I think what this is implying is that 6 is going to be, yeah, the next smallest number cannot be set to 5. Everything else can be set to whatever you want. But if you have 6, you can say 11 mod 6 is 5, aka 11 minus 6 is 5. So you want the second smallest number minus the smallest number plus 1. No, it's not quite. It's very close to that though. Let's see, this is 5. So if you had 6, it won't work. Which makes sense, because you can't get anything to be even close to 5. You need this to be, I guess, 0. And then you could just have everything be mod itself is 0. Okay, that's the same for this. For this one, though, everything's large enough that it minus... you can always have it mod it minus 5 and get 5 up to the 11. So I think it's going to be the min... think it's going to be min of the smallest number and the second smallest number minus the smallest number. Or the max of those two things. Not the most rigorous proof, but... Let's see. What am I looking at? Yeah, okay. I could sort it and whatever, I don't care. Is that how many I want? Yeah. That should be fine. It doesn't need to be this slow, but whatever. You could always set it to be at least the smallest number, because then you say everything mod itself is 0. And if you say the smallest number, even +1, if you said, no, I'm going to shoot for better, I don't want mod 5, I want to disallow that, then everything has to be at best 5. You can't have it be above the second smallest, because then the second smallest cannot change. Are they... I think they might not be distinct. Oh no, they are distinct. Okay. Whatever. Max of first and second minus first. That works for the inputs, so. It's a little bit deceiving though. 525. 526. I think it's +1 minus the first. Right? No, 11 minus 5 is 6. Why did this do 5? Oh, 8, it's 0. Yeah, if it's mod the second number minus the first number, everything past that doesn't matter. The second number, that's the largest amount where you're still able to make the second number be equal to the first number. Okay, I'll go with that, I guess. That one I might have to come back to. Penguins are civilized creatures that communicate using permutations. Black selects as a penguin researcher must study their means of communication for a given integer n. Consider permutations p of the array 0 through 2n minus 1. Okay. S of p. This is S of the permutation. Is the sum of the pop counts of the prefix and of this permutation, where pop count at z is the number of 1 bits. In the binary representation of z, for instance, pop count of 5 equals 2, because 5, blah, 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 blah. Okay, permutation is considered sacred if it maximizes S of p. Find the lexicographically minimal sacred permutation. Interesting. Well, these are sort of at odds because, man, how many years have I been using Firefox nightly and it doesn't autofill basic URLs? This is kind of at odds because, like, the prefix pop count is going to monotonically decrease, right? So you want to start, or the prefix and subsequently the pop count is going to monotonically decrease. So you want as many elements as possible. You want as many ones to be set as possible as early on as possible, or else it won't be the maximum. So you would necessarily want to start p at 0 as all ones, so the final element. And then if you went to p at 1, you would say, I think, just that It would be like reverse counting. So we usually have like 0 1 1 0 1 1 1 0 0 1 0 1 and so on. It would be the opposite of that. So you'd start at 1 1 1 and then you would go to 0 1 1 and then, right? You would yeah. Let me think about this. So you start out, you necessarily have all ones at the start. You need, all things being equal, you need the smallest next thing that's going to maximize the pop count, which I think you could just necessarily say is this. Everything is equal, the indices don't matter, except that it needs to be lexicographically the smallest. Therefore, you put a 0 there. But what do you do next? How do you keep it maximized with distinct elements? I think you could say 1 0 1 1 1 0 0 1 1 1. Right? So wouldn't it just be a backwards permutation? 3 1 0 2. So 1 1 0 1 1 0. Yeah, no, it's not quite a backwards permutation, but it's very close. I think you could just generate a forwards permutation and then reverse it at every power of 2. And it would be n log n to do so, or you could just directly derive it. First thing is going to be minus the largest bit. And then minus the largest bit minus 1. So I think what you could do is encode it backwards, because really you're saying this is the same as 1 1 0 1 1 1 0 0 1 0 1. So if we keep going, we would say 1 1 1 0 0. Would it be that? No, you would want all of these to be 0. And in fact, you would want this, I think. Yeah. Well, you can bucket these according to their bit length. And then I think it is reversed. So you'd say, take away 1, take away 3, take away 2, take away 7, take away 6, take away 5, continued on. So now I just need a way to transcribe it to be that, which is kind of confusing, but I don't think it's that bad. It's kind of bad though. That's actually like kind of frustrating to implement. But you would do that. I just need a way to reverse the bits. I mean, I could just express them as a binary number. I could also just hard code it. I think I'm going to hard code it. So you're going down from powers of 2 minus 1. You're starting at 0. What am I doing? I'm just inputting a number. Okay. For bit length in range from 1 to this is going to be the power of 2. So I'll call this limit. Previous limit is going to be that. I'll say for lim is equal to 2, lim is less than or equal to n plus 1. Right? How's this going to work? 3, 0. No. N is in terms of that. So we would say lim is less than or equal to n. Limit goes up. For I from 1 to the limit minus 1. I is greater than the previous limit. I is going down. Let's see how this does. Weird way to draw it, but it should work. So this is saying, I must just care about that. What is res saying? Oh, it's a bunch of gibberish. I need this. 1. Okay. So it's saying here you have 1 and 0. That's true. This one is 3 and 1, which is also true. So that's to a good start. Okay, that's working as intended. This one, I want to say flip it and then add it into mask. So int cur is equal to mask while I is greater than 0. Let's see the bit. This is how I'm gonna rotate it. Kind of want to just take this. Yeah, that's good. These are really wonky though. I don't need this anymore. Okay, I have the mask. I have the bit length of the mask. And now this is gonna say cur XOR equals. It's gonna be kind of confusing. I goes down, bit goes up. This is gonna be cur XOR equals 1 to the, no, I and 1 to the bit length minus bit, I think. And then once that's done, a new number has been synthesized, and then I can say res.push back cur 315. Fuck. Okay, it's probably off by 1. 3102. 2179. I just want to see, I want to like actually do a virtual and be like, okay, what ranking would I generally get? Because usually I don't even try to do anything speedily on Codeforces. On Leetcode, I'm pretty speedy, but on Codeforces, I'm slow as hell. So what happened here? Res.pushback cur. I is 1 to the lim minus 1. I is greater than p lim, I minus minus. So I should be good. It's saying 0 and then 2, which I think is what I want to see. I don't... maybe I'm just pushing I? That's not right, though. For sure, that's not right. Wait, why is I just 0 and then 2? I think... Wait. If... Let's just isolate test case 2. I is 0. Oh, no. That's just because I keep... In fact, no, this is n is equal to 2. So I actually don't give a shit about what this is always going to be 0. I care about this. There's a contest 4 hours ago. Yeah, actually that's part of my simulation is that I submitted a bunch. They're still in queue. So we'll see. I've been going for half an hour, so there's a chance maybe I'll just get no questions right because they'll all be in queue. That would be unfortunate. Yeah, I saw it was like the Hello Year contest or something. Okay. I is 3 and then 2. And what this should correspond to, in my mind, kind of confusing, is that these are flipped. So 3 XOR 3 is 0. Too early for my time zone. Yeah. 3 XOR 2. 3 and then 2. But it's not 3 XOR 2, it's 3 XOR the reverse of 2. So I think I'm going to actually make this a lot simpler for myself. I'm just going to say mask XOR cur. I don't have to deal with mask. And then this is going to be if you took the bits in the number and you flipped them. So bit, do I need bit anymore? No, I don't need bit anymore. What I can say though is for int bit is equal to bit length minus 1, bit minus minus, bit is greater than or equal to 0. Okay, and now, in fact, I don't even really want to say that. I think I want to say and I doesn't equal 0. And then, oh no, this is going to fuck up because I'm like reusing I. So I think, whatever, I'll just say in x equals I. That's fine. X is greater than or equal to 0. X is going down. Okay, and now I can just say cur XOR equals 1 to the bit times x and 1. This should be a little cleaner. So what I want to see is this is swapped and then XORed with the overall mask, which is 3. So 3 swapped across all the bits is just going to be 3 again. XORed with 3 is 0. 2 swapped across the bits is going to be 1. XORed with 3 is 2. 3, 1, 2, 3. What's going on here? There's a lot going on. Three got flipped to 1, which is wrong. So what happened there? How did it get flipped to 1? It should just still be 3. 1 to the bit. So the bit length should be 2. I mean, maybe. I don't think that's supposed to be like that. Oh, maybe that is supposed to be like that. So bit equals bit length. Cur XOR equals 1 to the bit, but isn't the bit length... This is the sloppiest thing ever. The bit length is the power of 2. It's not actually the number representing the power of 2. Oops. Whatever. If it works, it works. And it should append nothing to the first thing. Okay. I guess I'll just revisit this one when the time comes. This feels like the kind of thing where like it's just kind of annoying implementation. And I think the more that I think on it, the more that I'm like looking at other stuff, I'll come back to this and be like, what the hell was I doing? That was trivial when the error inevitably shows up. But let's try something. Let's do like 1, 4. Okay, well, it's a good thing I tried that. What happens if we try 3? So this should never have a number greater than 7. Right? 3102. The next one should be something like 7, 6. I think it's going to be 7, 6, 4, 5. So why did it not do that? No, that's not right. Yeah, 7, 3. It should not be 7, 6. It should be 7, 3, but then 11 is way off. Should have 7 and then 0, 1, 1, 3, 1, no, 0, 0, 1, 1, and then 1, 0, 1, 5, and then I think I see the issue, actually. And then it didn't show up with an earlier power of 2, but then there's no way to keep this 1 the same. So then from then on, it's just everything minimized. So 0, 0, 0, 0. There's 2 more numbers, so they should just be 4... No, there's 3 more. So 2, 4, 6. All right, 0, 1, 2, 3, 4, 5, 6, 7. Okay, what if I tried 15? So I know that it's immediately going to be 7. And then any number there's n over 2 numbers that have a 1 here. Those are immediately taken off, right? Those are like immediately going to be at the end. But I won't think about that too hard. And then 0, 0, 1, 1 is 3. And then 1, 0, 1, 1 is not 11. Yeah, 11. Okay, let's get rid of that. 1, 0, 1, 1. Now the only thing left to do is take the next thing off. So it'd be 0, 0, 0, 1 is 1. And then all of the, like, increasing numbers from 1. So this would be, next we would fill this spot, right? So it'd be 0, 1, 0, 1 would be 5. And then we fill this spot. So 0, 1, 1, 1. No, we already did that one. We need to retain the bottom one. This stays the same. We need some other configuration of stuff here that retains that. We already have this. We already have this. We already have this. We already have this. And this. 1, 2, 3, 4, 5. So I think we're missing one more. 2 and this. So 1, 2, 3, 4, 6. I think it's just this, right? It should be 13. Yeah, and now there's 7 of these, which means every other number has been encoded in this. So then it's 0, 0, 0, 0. And then everything that comes after that. So 1, 0. And 1, 0, 0 is 4. So I guess what I'm noticing, I think a better way to do this that's just going to be faster is that everything before this point is odd and everything after this point is even, and then everything before this point is has a 4-bit set and everything after that point doesn't. This is just going to be increasing even numbers. This is going to be increasing numbers that don't have a 4-bit set. These. This is going to be increasing numbers that don't have a 2-bit set. I'm sorry. This is going to be increasing numbers that have a 2-bit set but don't have a 4-bit set, and this is going to be increasing numbers that don't have an 8-bit set. That are all the numbers left. So you could do this in n log n, right? You could say, take out every other number. No, because this is not increasing that. It's not 11, 15, 13. That wouldn't even be right. It's 11, 1, 5, 13. So these would need to be reordered as well. I don't think these need to be reordered because there's no additional constraint. So it would just be 6, 8, 10. What's going on here? 12, 14. So these are increasing even numbers. Eleven, 1, 5. No, wait, that is right. No, I just drew the line in the wrong place. Right? I don't fully understand the number of each of these. Like, this is going to be n over 2. Or I guess 2 to the n minus 1 if it's the power of 2. Why would this not be half of that? This is 1, 2, 3, 4, 5, 6, 7, 8 numbers that all end in a 0. And then everything else, you have 7 numbers that end in a 1. Or you have, yeah. And then of those 7, you have 4 numbers with a 4-bit set. Is that right? 4 numbers that end in a 3. Okay. I think the thing to do is you just start with every number. You start with the full permutation. You go backwards and you say, if it's even, put it in the result. And then take out all the numbers that you put in the result. Now you have this. And then go backwards again. If it doesn't have a 3-bit set, then put it in the result, going in descending order. If it doesn't have a 7-bit set, put it in the result. If it doesn't have a 15-bit set, okay. And that would be O of n log n, so that should be fine. I think I'm literally just gonna rebuild this because that was kind of a waste of time. Res, that looks good. Dot reserve, limit, that, and then I'll say bit set. How large can this be? 16. Scene, and then I think I can say scene dot set. What is setting the prefix to 1? Is it just set from 2? Set a single bit, set a range of bits. That's fine. Dot set 0 lim true, right? Whatever. Okay, they're all seen. And then while res.size is less than lim minus 1 lim for I is equal to lim minus 1, I is greater than or equal to 0, I minus minus. Mask is going to be equal to, I want to say anything that doesn't have a 1-bit set. So I'll do that. Oops. And then I'll say mask is equal to mask going up. So it'll be 1, 3, 7, and so on. What happened to res? Oh, res is down here. If scene at I continue, I guess scene will be I haven't used it yet. Or seen will be I haven't removed it yet. So if mask and I doesn't equal mask, then I is missing some bit from mask. Res dot push back I, and then mask goes up. Okay, let's see how this does. 0, 1, 2, 4, 5, 6, 7. Oh, that fucked it up so bad. What the hell? Well, I said seen at I equals 0. That's gotta... What did I do here? Seen at I is 1. So don't use things you've already seen. 1, 0, 2, 3, 4, 5, 6, 7. Oh boy. 3 and then 7. That's honestly what I want to see. What is res filling with? It should immediately fill with all even numbers. It should say mask at I doesn't equal mask. This should, when mask is 1, it's saying when 1 and I doesn't equal 1, therefore I is not equal to 1. Or sorry, I is not odd. I is even. For 6, 4, 2, 0. That's correct. Right, so what happened here? It's really weird that I'm going largest to smallest and then reversing it, and I'm not really sure why I'm doing it that way. Okay. 0, 2, 4, 6. That seems right. Right, so why does it fuck up beyond that? Or maybe it doesn't fuck up beyond that. Maybe, I don't know what I just changed, but maybe that fixed it. Maybe I'm overthinking it. Seven three one 50246. Does that match up with what I thought it would be? 731500246. 157311 157311 Okay, I guess I forgot 9. 9 13. That explains why there's a 3 here instead of a 4. That was really confusing me. 0246. Okay, that seems right. This seems more reliable to me. Kind of a shame this took so long. This didn't need to, but that's okay. And who knows? Maybe it's still wrong. Is this the right thing? Yes. Black Slicks. After failing to pick up a girl using De Bruijn... Uh-oh. I don't know that. Sequence of fixed length bit string. Maybe I do know that. Fixed length bit strings. Black Slicks has turned his attention towards politics. Due to his high charisma, he is now in charge of drawing borders for the N voting districts in his country. There are X voters for Party A and Y voters for Party B. What is this gerrymandering? His history with bit strings has led him to wonder if he can allocate voters such that the winner of each district follows a certain bit string pattern. To avoid suspicion, he must allocate at least p sub I voters to each district. Tell him if it's possible. Formally, you're given binary strings S of length n and an array P of length n. We're given n, x, and y. You want to determine whether there exist two arrays of non-negative integers, a and b of length n, that satisfy the following conditions. Okay, there needs to be at least that many voters in each district. They need to add up to the number of voters. And that number needs to be greater than that only if S at I is true. This seems like a min-max kind of thing, right? Because if this is larger than this, you can have, let's say this 1 or something. There needs to be 4 people here. That means each number is going to be anywhere between, I guess 0. Right? I think you can have 0 voters. 0 and the other number. So you keep a left and right bounds. And you say, is there any point at which it becomes impossible to obtain X or Y, given a minimum and maximum X and Y? So you'd say I need 5X and 5Y. You'd say here, this is 0. And I need to allocate 2 people here. Therefore, at least 2 people here. I don't know if a greedy approach would work. Greater than or equal to P sub I. You can't go below that. Man, that's rough. So this idea of greedily maintaining left and right bounds, I think that's might not work because you don't know how many people to have put here when you get to here. I guess you kind of do. You kind of do know that though. Right? You could say, yeah, I think you kind of do. You say, okay, ignore the 4 and the 3. I don't give a shit about how many people I have to attribute to the future. When I'm here, I have to attribute at least 2 people. And the amount of people I put into X has to be more than the amount of people I put into Y. Therefore, this number could be anywhere from 0 and 2 up to, do you just maintain a difference? That's kind of weird. I don't think you'd want to do that. You could have anywhere between 0x people and yeah, is it worth just thinking about the difference between X and Y? I don't think so. Because in this first example, if X and Y were equal to 100, then this problem would become trivial. Because you'd have so many leftover X and Y to just put in random places, you could just easily increment anything by 1. So maybe that's the secret though. Maybe you say, what if I tried as hard as possible to gerrymander towards X? What if I tried as hard as possible to gerrymander towards Y? And then anything in between those is possible. So here you'd say, if you tried as hard as you could to gerrymander towards X. Wait, what the hell is even the goal? To have the same amount of people. Okay. Yeah, you'd say, if SI is 0, A at I is greater than B at I. So you'd say, this is 0, so I can just go crazy with this. This B at I has to be greater than A at I. And there has to be 4 people. Therefore, the minimum amount I could give to I is 1, in theory, right? Why would it not be? I guess it would be 2. Because you'd say this is an even number. So the closest I could get is to say 1 goes to X and 3 goes to Y. Otherwise, if it's 2 and 2, they'd be the same, and that would invalidate this. Whereas if it's an odd number, you can have a difference of 1. You could say one goes to X and 2 goes to Y, versus 1 goes to X and 3 goes to Y. So if they're even versus odd, that's going to affect the minimum. So you could say, okay, if you're trying to gerrymander the most for X, I think parity is going to get in the way. It's going to be kind of stupid, but I think there's a world where you have like S is that, X is equal to 2, Y is equal to 2, P is equal to 4, and you'd say, no, I think my thing would account for this. It would be smart enough to say this is even, therefore you can only have a 3, 1 and a 1, 3. Those are the only actual configurations that satisfy this. If you're trying to minimize or maximize X and Y. And no, yeah, I would need a statement that would be like, you've never had any point where there's any parity difference. Therefore, while yeah, the minimum and maximum bounds are 3, you can't have a 2. So I would need to account for parity. Okay, 3 accepted. That's kind of nice. Was this the one that I thought was going to be bullshit? Maybe? I don't remember. No, I thought that one was fine. Okay, let's take this example. See how it goes. So you'd say if you're trying to maximize X, I think you would just say the moment that there's a single odd parity in here, you can now have any number in this range. And if there wasn't, you'd be in trouble. But okay, if you tried to maximize X, you'd say right here, does the sum of P, this, well, you could also just check, I mean, the sum of P needs to be less than or equal to X plus Y. If it's greater than that, then you're fucked. So here it's exactly 10. So there's exactly one thing you could do. No, there's not exactly one thing you could do. Right? Yeah, P sub I is just not related. So if sum of P is greater than X plus Y, return false. It's not possible. So if you're trying to maximize x, how many x could you possibly put in? Well, I guess you could put in 2 here, right? Wait, does this even mean anything? If you try to maximize and then say, is everything in between that valid? Because the moment that you have anything, any s equals 0, you could just say, we'll put 1,000,000 x in here. So what am I even saying here? Maybe I'm saying you're trying to minimize x and y. So here x has to be at least 2. Yeah. And then you don't need any x here. And then x here has to be at least 2. So you need at least 4x to make this valid. And then for a minimum of y, there doesn't need to be any y there. There does need to be a y here, so it needs to be, you need at least 2y, right? That's kind of weird logic, though. Does that really make that much sense? What if you did say the difference between x and y? So if you try to minimize the difference between x and y, you're going to get, there needs to be a difference of 2, there needs to be a difference of 2, there needs to be a difference of 1 is equal to 5. So if you assigned the minimum possible amount here, but it wouldn't be +2, it would be -2, +1, right? Because you're saying like difference, it matters whether it's the difference between x and y or y and x. But then wouldn't you have a bunch of extra? Because you'd be saying, I'm using 0x. No, I'm using 2x and 2x. And 1x. At minimum, I need to do that. Is this supposed to be false? Oh, nice, it's accepted. That feels good. No, it is possible. 203,041. Huh. This doesn't seem, it feels like it shouldn't be this difficult. I feel like I'm just kind of brain farting. Is there ever any downside to... Yeah, I feel like maximizing and minimizing x and y is the way to do it. What's the least amount of y you need to be able to do it? What's the least amount of x? What's the... But it's kind of weird, because what does that mean? You still need to be like given the amount of y that there is. No, but if you know x plus y is greater than or equal to the sum of p, if it's less than that, you just can't do the problem. And if it's greater or equal to that, then you can just find the minimum amount, right? So you could just say the minimum amount of x you could possibly get to scrape by would be three. Because it would be, no, it wouldn't be 3. It would be 4. Because this needs to be at least 2. This needs to be at least 2. The minimum amount of y is 3. And you have a parity. So therefore you don't really need to worry. A situation where you would need to worry is this. You would say the minimum amount of x you need is... No, this would work. Yeah. Because you'd say minimum x is equal to 0. You don't need any x to satisfy this. The minimum y is equal to 3. And you'd say, yeah, x plus y does equal 4, but I need more y's than I have in order to make this possible. Is there any world where, what if you had like this, S is 1, P is 4. Wouldn't this be impossible? Because the minimum x that you need to use is 0. The minimum y that you need to use is 3. But this is not the end-all be-all metric. Right? Because there's only one thing. So you would probably need some sort of like, if you had like 1, 0 and 4, 1, then you'd be fine. Because you could just say, okay, 4 y's go here, 4 x's go here. So I think if there's, I guess you want a maximum as well. And the maximum would be infinity if there's a 0. But if there's not, you'd say, what's the maximum amount of x I can possibly put in before I invalidate this? So if you had like 1, 4, 1, 4, you'd say, well, now the minimum y would be 6, but fine, let's say we have 6 here. Is there any way to do this? Now there is a way to do this, actually. You would just say 2 and 3, 2 and 3, right? And then that would work. But okay, let's say this. So you'd say the minimum x you need is 0. The minimum y you need is now 6. Because you need 3 in both of these in order to make it work. The maximum x that you need, you can't have any less than 2x. Or you can't have any more than 2x without tripping one of these. But that's not really true either, because what if we had excess y like that? Damn, 400 people already got this? Oh. $423.20. The answer to this is no, for precisely the reason I'm pointing out. That you have too much x, right? I feel like if this was even one less, if it was 1, 1, 1. Wouldn't you be able to say like 2, 1, 2, 1, 19, 18? Okay, but then the moment that you add this on, it's too large. Yeah, what's the problem with just like greedily conserving as many x or as many y as possible? It's not guaranteed that one of those two things will work, but it is guaranteed that if those work, then anything in between also works, right? As long, like, there might be a weird parity rule, but... So you're just trying to see if I invest as many x and as few y as possible, is that possible? If I invest as many y and as few x as possible, is that possible? So this would be, you're seeing about conserving y's and it's not possible. If you were seeing about conserving x's, I think you would just say 2, 0, 2, 0, 2, 0, 2, 0. And then you'd have some leftover x and y. Which does work. So if you try to conserve as many y as possible, do you have enough y? If you try to conserve as many x as possible, do you have enough x? Okay, back to this example. If you tried to conserve as much y as possible, conserve as much x as possible, you would just say 0, 4 gets you to -2, but as far as x is concerned, that works. Y would be conserving as much y as possible. So this needs to be 3. Okay, that works for that. Here, if you're trying to conserve as much x as possible, you'd say, okay, x needs to be greater here. So this needs to be 2, 0. Y needs to be greater, so you could just do 0, 4. And then x needs to be greater, so you could do 2, 1. It's going to get you 1, 0. Checks out. If you conserved as much y as possible, you'd say 2, 0, 1, 3, and 3, 0 gets you. So that checks out. So you would return true. The only missing piece is the parity, because there's some, I don't think there's any world where if you have enough x when you keep all of them and you have enough y when you keep all of them, there's an in-between that isn't possible except for possibly a parity. So if you had s is 0, 1, x equals 4, y equals 4, what happens if you have this? This would be 3, 1, 0, 4 equals 3, that checks out. Ry is equal to 4, 0, 1, 3 equals 3, that checks out. You could say 3, 1, 1, 3, that would work. So there's no parity issues here. What happens if we had like y equals 5? It doesn't matter, because the moment that there's a 1, you just put everything in there. Okay, I mean, the test cases are pretty extensive. Let's see. Yeah, I'll code this out and see how it does. Sum is greater than x plus y, then it's not possible, return. Okay, this is the minimum amount you can possibly spend on x. If s at I is 1, it's not relevant. If s at I is 0, it's going to be divided by 2, rounded up. Right? No, I don't even think it's going to be that. It's going to be over 2 plus 1, not plus 1 over 2. Rx is less than or equal to x, and Ry is less than or equal to y. Let's see what this does. Yes, no, yes, yes, no, no. Yes, no, yes, no, no, no. Okay, this is the situation where excess matters a lot. So in the world where everything is 1, you need to count up the difference. So if they're all 2, you need 2 more y than x for all of those. Yeah, okay. What is this actually saying? This is very confusingly written. O is 1, Z is 1. This is, you've seen at least a single one of these. If Z is 0, you haven't seen a single Z. You need to go through and calculate the maximum amount of X you can put into anything. So you'd say, I need to put in I mean, I feel like you could just brute force it really weirdly. You say, try putting in 2y and 1x, 2y and 1x, 2y and 1x, You would already return false if there wasn't enough y. So you know there's enough y. Therefore, for all of these, you could put in one less x than y and see if it works. So you'd say, there's 4 places where I need one more y than x. Therefore, I have 19 spare y. No, not 19. 15 spare y and 16 spare x. No. Times 8. You put 2y, 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 2y. I have 15 spare y and 16 spare x. Therefore, it's impossible to make there be less x than y everywhere. So this will be y minus equals the number of ones. Or I guess I could just say if y minus the number of ones is less than x, then return. Right? And then it's the same thing for the number of ones. So if x minus the number of zeros is less than y, then also return. Yes, no, yes, no, no, no. Yes, no, yes, no, no, no. I think that's good enough for a submit. I don't know. There's no way this TLEs. Okay, good. Wow, surprised I got that first try. Black slicks and another RGB walking. There's 2 players, player A and player B. Jury will first interact. Oh, what the hell? Oh my god, I don't want to do that. Ooh. Okay. The jury will first interact with player A. After player A ends their interaction, the jury will interact with player B. Note that player A and player B may not directly pass information to each other. Both players are only able to send information, receive information from the jury, but they may agree on the strategy they will use to communicate. The Penguin Republic is a bipartite connected undirected graph G with n vertices and m edges. Black Slicks is going to conduct forbidden field research at vertex 1. Due to travel restrictions, he'll be dropped off at an unknown vertex V. He must get to vertex 1 while having no information on the graph. For his journey, he has bribed a penguin agent and agreed to some communication strategies in the following method. The agent will discreetly mark each vertex in one of 3 colors. Interesting. Red, green, or blue. From Black Slicks' perspective, he will see only one color, only the color CI of each neighbor UI. V. This is a weird way to write this. You must choose some J and move to vertex U sub J such that he's closer to vertex 1. Note that the neighbors are arbitrarily ordered. He sees only the colors of the neighboring vertices and not the vertex that he's on. Additionally, he does not know the index of the vertex he's on, the neighboring vertices, or any other vertex. task is to implement the strategy for both agent and black selects. For agent, you must color each vertex in one of 3 colors. For black selects, you're given Q queries. In each query, you're dropped off at an arbitrary and unknown vertex V, and given the color neighboring vertices, you must determine a vertex to go to such that you're closer to vertex 1. Oh, just a single hop? Well, it's bipartite, so all you really need to know is how does that matter? Okay, the first line of the input contains the string first. The purpose of this is so your program recognizes this, okay? Test cases. The first line of each test case contains 2 integers n and m, the number of vertices and edges respectively. The following m lines contain information about the edges. Okay. Each test contains multiple test cases. The first line of each test case contains 1 integer. Number of queries. The first line of each query contains 1 integer. Here we can see the light mode developer in his natural habitat. It's pretty bad. It's pretty bad. I mean, what I have on Chrome is great, but it does not, like, their like background thing they have going on right now, not a good match with dark mode. This is so weird and hard to read. This feels like a 2001 website. So I'll stick with light mode even though it's painful. The input of the second run is not adaptive. In other words, the input of the second run will not change in different runs. Interesting. Okay, huh. So the first line of each query contains 1 integer d of v, the number of neighbors in the vertex v that black selects is currently on. I see, okay. So that's why they're talking about the number of neighbors and the index of the neighbor. They're saying you have no information about anything other than what are all of the colors of all of the neighbors of this. So you don't get the ID of the neighbor. You only get the number of vertices. So, okay. The next line of each query contains a string C. This has the colors of each neighbor that you chose previously. The characters in the string are R, G, or B. It's guaranteed that the sum Q does not exceed 10 to the 5th over all queries. The sum D does not exceed 2 times 10 to the 5th. Over all queries, okay. The input of the second run is not adaptive. In other words, the input of the second run will not change. That's great. Okay, output. For the first run, for each test case, output a single string s of length n minus s sub I. What the fuck does that mean? Of length n. Oh, I think this is like an m dash. That feels very AI. S sub I. The color of the eye of the vertex painted by the agent. The characters in the string are R, G, or B. For the second run, each query in each test case, output a single integer j. uj is the neighboring vertex that black selects will go to next. Well, I guess you can immediately prove that what if you had, no. I was gonna say, what if you said, so I'm trying to color code these in such a way that given a random vertex, someone else, me, would be able to immediately know which one is going to get the closest to vertex 1. right? The agent will discreetly, blah, blah, blah. Each neighbor, he must choose some j and move to vertex u sub j such that he's closer to vertex 1. That's very interesting. Okay. So we have some graph. And we need to say, and it's bipartite, if I'm not mistaken. Bipartite. So that would make this not valid, but that could be valid. And that could be valid. So if you have this, let's say this is vertex 1. And you start out here. Both of these are going to be the same distance away, so as long as you don't choose this, you're fine, which would be pretty easy. Is there any word where you just BFS out from vertex 1? Yeah, what if you just BFS'd out and you color coded it in rings of 3? So you said, these are blue, and then these are green, and then these are red. I think that would just straight up work, because then you would say, red always wants to point to green, green always wants to point to blue, and blue always wants to point to here, because the difference between depths will never be more than 1. Okay, I feel like that's just straight up what it is. It's gonna be kind of confusing. If type equals first, then I guess what, solve 1? I don't know. Each test case, okay. So I'm generating the inputs to my own test cases, I guess. First line input. Okay. I think what I want to do is this. What's the problem here? Too many arguments, that's solvable. Okay. Okay, now what's the actual input for this? No, that's the first, okay. Or that's the second. I get n and m, the number of vertices and edges. That's, okay, that works out. Let's get the edges. Following m lines contain information about the edges. The ith line has 2 integers, ai and bi. They are connected by edge I. Okay, great. So, right, 2e5, 1e5. Let's do that. Okay, built adjacency list. Now I just need to BF this out from 1. So I'll say vector char res dot reserve n, right? And then in the end, I'll say string s res dot begin res dot end print s. Okay. And then the last thing I need is like a map. So I think I can just say map char to char next is equal to, how do I do, can I do this? That doesn't sound right. I think I can do this. I'll say R leads to G, G leads to B, B leads to R. Right? Well, these are fucked up. Okay, what's wrong with this? Nothing. That works out. Great. Let's get prev in there. So R leads to B, B leads to G, G leads to R. Great. I just want to see quickly. So cur equals next at cur. Print cur. Right, this should be saying there's one test case which has no vertices or anything. So this should just print R and then, what's going on here? 4. Oh, I forgot to bring this over. Great, RG. And then if I said previous occur, that should just be RB. Okay, cool. So that works as intended. I think I don't even want cur. I think I want stack. I also want bit set scene. Let's do that. Scene at 0 is 1. Stack. Pair int char stack dot in place 0 R. Oh, it's not a, I don't want a stack though, I want a queue. While queue is not empty, auto uc equals q dot front. The front of the queue, right? Next element is the oldest element, yeah, okay. Removes the first element. for int and ADJ at U, if seen at V, continue. I mean, I'm always setting res to be the same for everything. So why would I not just say that? Right? And then here I can just say res at V is equal to, well, I can say C is equal to next at C. Res at V is equal to C. Am I overthinking this? No, not really. I mean, kinda. I think what I'll say is res at U is equal to C. And then here all I need to say is stack dot in place V next at C. Except it's Q. Q dot in place C V next to C. And seen at V equals 1. Res plus n. Print s. That looks pretty good. So now I've color coded it in such a way that you always know exactly what color to go to. So the initial vertex 1 is colored in red. All the immediately adjacent elements are green. All the next elements are blue. Therefore, if you're at green, you want to head towards red. And if you're at blue, you want to head towards green. So I think this is going to be very simple. I can just say print S, that one looks good. Okay, second, get the test cases. Get the number of elements that are going to be neighbors to the element that you're at. The first line of each test case contains one integer q, the number of queries in this test case. The first line on each query contains one integer, the number of neighbors. Contains string C of length dv. I'll call this n. This is going to be the length of neighbors here, and I also want like a that, and then in the end, what am I actually printing for the second line? Output for the second run, each query. For each query in each test case, output a single integer j that is the neighboring vertex that black selects will go to next. I think I probably want that to be 1 indexed. Right? 1 is less than or equal to I is less than or equal to, yeah. What's my time? Oh, I can get this easy. One integer, I've got d, string C of length that. The ith is the color. Okay. But I don't think I know the color of the current. Damn. That makes it a lot trickier, I think. So you don't know the color of your own vertex. But it is bipartite. No, that's not bad at all. Wait, I don't think that's bad, right? You can just deduce the color of your own vertex. Because you can say whatever's not there, that's the one that I am. If there's multiple that aren't there, there's only one thing to do, so you just go to anything. That's not bad. Yeah, the fact that it's bipartite actually handles that. That's where that comes in. So, int r equals 0, g equals 0, b equals 0. For I from 0 to n, if I'm just going to write this explicitly. That's fine. If s at I is equal to r, r equals 1. Same with G, same with B. Okay, now we know exactly what's there. Self is equal to, well, first things first, if sum, if R plus G plus B is not 2, then that means that there's only one thing you can do. So if R equals 1, res1 dot push back R, that's the only thing you can do. Okay, that's the case where there's only one thing. I don't think any world where there's going to be 0 neighbors. That would be really weird. Int self equals, well, no, wait, if this is less than 2, all of your neighbors are the same color. Therefore, no matter what you do, it doesn't matter, right? I don't know what I'm on with this. R. This is R equals 0, question mark, R, or else B equals 0, B, or else G. So now you have yourself. Int best is equal to previous at self for I from 0 to n, if s at I is equal to best, then that's the one that you want. So res1 dot push back I plus 1, close 1. So you always go to the first element if it doesn't matter. That's what this is saying. Or else you find out what you are, you find out what the next thing you want to go to is, and then you go to that. That looks pretty good. That's not supposed to be there. Get the number of elements, see which neighbors exist. See if there's only one neighbor, go to that if that's what you need to do. If there's more than one, then find out what you are, go to the previous thing. Okay, and then in the end, wait, I think that there's supposed to be this here. This should solve, okay, yeah. print res1, right? For each run, for each query in each test case, output a single number. So this should output 2 strings of some sort. RGBBBGR, RBBB. Let's see. 1, 2, yeah, I guess I'll go through this. Right, how much time do I have left? 30, yeah, that's fine. Is this, yeah. So 1, 2, 3, 4, 5, 6, 7, 8. 1 goes to 2, 2 goes to 3, 1 goes to 6. 1, 2, 1, 6, 3, 2, 4, 2. 4 goes to 2. 6 goes to 4. 4 goes to 7. 5 goes to 6. And 5 goes to 7. Okay. Okay, whatever. So we're trying to get here. So this is red. This is going to be blue. This is going to be blue. And then this is going to be green. This is going to be green. This is going to be green. And this is going to be red again, right? That's what mine should output. So it should output red, blue, green, 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 blue, red. Red, blue, red, green, blue, 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 green, red. Does that really matter? Okay, I had it backwards, but whatever. So it's red, green, blue, 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 green, red. That one checks out. And then it should say for any given thing. I like what I did for question D. Yeah, question D was kind of cool. 1, 2, 1, 3, 4, 2, 4, 3. So this is just a square. This should say red, green, green, blue. Yeah, that's right. Okay, so the first query type is correct. Let's see about the second query type now. So I guess we just pop this on, right? So this should say there, it's very confusingly written, but there's two test cases you care about. This test case has 2 queries. I think it's basically going to be nonsense. Communication problems are a nice addition. I think this is not going to mean anything because the way that the colors are encoded are not going to be the way that my colors are encoded. So I'm just going to go off the fact that like this is what I want it to be. I'm pretty confident in the solution here. I guess I'll make sure that it at least prints something out, right? Second, well, yeah, okay. Will this at least print something out? Yes, it will. So I'm happy with that. 1, 3, 1. Okay, it even prints out what it wants it to print out. So I don't know what that's supposed to mean, but I think for the sake of not having like weird problems, I'm gonna say for auto X in res1, print X. I'm gonna have them on different lines because I could see that being like a weird communication thing. Okay. I think the initial rush is over. Now it's gonna actually be like real-time feedback. Damn. Wrong answer. Shit. I'm certain of this solution, right? Like, the nature of a BFS is that the depth of anything with regard to the BFS will only ever differ by 1 from all of its neighbors. Or 0 or -1. So with any BFS, if you know what you are, let's say this was selected. You can say, I have a neighbor that's green, blue. I have a neighbor that's blue, and I have a neighbor that's red. This should be smart enough to say, and now go to red, because there's never any world where red is going to be a depth greater than this that you're connected to. So why would it not do that? Right? I feel like that comes down to like a weird implementation error. So red points to green, green points to blue, blue points to red. There should be the reverse of that in all these. So red points to blue, blue points to green, green points to red. Okay, next and prev are fine. This is saying fill up an adjacency list, so create the graph. Now you have scene. Go from, start with red. So any green should always want to point to red, right? I think it might be this. This might be cause. This is the only thing I can think of that I'm not like 100% certain of. So BFS out. Is there any world where I don't? I could see a world where the BFS is kind of fucked up for some reason. Why would it be though? This seems fine, right? Res U is C. Q dot in place that. Scene at 0 is 1. Res at U is C. This seemed fine. No, when I ran this, it was fine. Okay, S, print S, that's fine. VI res 1. So you're looking for each color, which colors are present. Based on that, if there's only one color, then just go to anything. I don't think there's any world where that's not the case. You just go to the first thing. Find out what you are. Find out what the best option is. Try to go to the best option. Looks good to me. I don't know. What the fuck does that mean? Wait, is this just the exact same? 2 4 2 1 3 2 4 2 1 3 6 3 2 1. Damn. Okay, I gotta go in 10 minutes. That would suck if I didn't get this. I have no idea why this isn't working. I'll be happy if I get this. Is it a problem with like reuse of variables? I don't see why it would be that. I use red 1. R, G, and B are never present up here. I have ADJ, res, and scene. Is there ever any world where it never sees best? That doesn't sound right. Great. For any given layer, it will always be, you will never be connected to anything else of the same depth. You'll only be connected to the other two colors. Is it a problem with one indexing? No. Is it a problem with it being too large? N 10 to the 5th, M 10 to the 5th. That should be fine. Do I reset the adjacency list? Do I reset scene? Yes. Do I reset res? I think I do, right? I think scene handles that. Oh, I use I here. That's what it is. I hope it's that. I really hope it's that. One self. Ooh, wow. That would have really made me sad if I didn't get that by the end. Oh man. Is that the only... Does that happen here? No. Fuck. For real? Damn. Okay. Res.reserve Q for I in range, input N, input S, for J in range. Res1.pushback1 continue. For J from 0 to N, if S at J is equal to best, to push back J plus 1. You know what I could do that's really jank? Is I could say int test123 is equal to 0 for I from 0 to that big number is equal to test123 times 7 plus 4% mod. I don't know, something like that. And then it'll just do this forever, right? And then I can see, is it that this is reaching 0? Is that the problem? That's pretty jank, but I only have a couple minutes left, so I guess I'll just try that. I don't see any world where it doesn't come across the best option. What would that mean? That would mean that, yeah, because this is saying you are red, blue, or green. Necessarily blue and green both have to have existed. There's no world where all three of them exist. So no matter what you are at this point, the best thing exists somewhere in your neighbors. No, I guess not. Time limit exceeded. So actually it's good that I did this. Works equals 0. So if S at J is equal to best, that means best never happened. Does that mean that there's no neighbors? That doesn't sound right at all. Let me run through this. He's bribed. He will only see the color Ci of each neighbor. If V, he must choose something to move to that vertex so that he's closer to vertex 1. You dropped off in an arbitrary and unknown vertex V, and given the color of the neighboring vertices, you must determine a vertex to go to such that you are closer to vertex 1. When would this ever not go through? So this is saying this isn't true. So R plus G plus B is indeed greater than or equal to 2. It's bipartite, so I'm almost certain that you cannot have 3. Right? I'm just going to run it. I'm really running out of time. I want to see, like, does this also TLE? I know it's going to tank my score, but whatever. So that means that your best thing isn't in here. If S at J, previous as self. Wrong answer. Okay. That means that that's not the problem. The problem is that it just doesn't contain the other thing. I guess I'm very confused in what world something is only adjacent to... So S at J is never... Oh, wait. Why is it int? Okay. Int... What problems would that come up with? I think that would come up with some pretty serious problems. Man, what a stupid error. All that for a pretty dumb error, hopefully. Or it'll still TLE, which would be frustrating. I mean, it's possible. Maybe it knows to cast int and char together. Damn, I guess it does. Damn, I have to go in 1 minute. That fucking blows. What the hell? It's map char to char. Well, this also needs to be a char. All right, well, I guess it's that. I guess it's just me habitually typing int. That's the only thing I can think of. Char self, char best. These can be int. That can be whatever. This is a vector of ints, so that's fine. All right, last try. What a moronic set of errors. I mean, if that's what it is, there might be a more serious problem. That's like bad though, that I would have that. This is the final moment. I'm not going to look at it anymore after this. Yep. Man, that's a shame. I felt like I had this. For real? For real? All right, I'm going to do one more Hail Mary. Okay, I have a couple more minutes. What would... In what world is it not connected to the thing with a closer distance, right? Maybe it's a problem with this. I really haven't been looking at this that much, but there's no way. Is it a problem with q.front? Q.front accesses the first oldest element, which is the next element to be removed, while q.back accesses the last newest element. No, that's fine. And I don't even think it should really matter, honestly. I mean, this could be a stack, right? No, you wouldn't want that. So this accesses the oldest element. It says color it. Go to the next thing. It's int comma char. That's what this would be. Scene at v is 1. I really don't see problems with that. S is res plus n. That seems totally fine. I can't imagine there's problems with that. I decrease them. There's 0 indexed. I reset ADJ. This is like I've covered this like 4 times. I mean, I can't imagine what world. So there isn't only one color. There's 2 colors that it's connected to. And so you know your own color. You know the color that's going to be closer. You're looking for that color, but that color doesn't exist. I don't know how that's possible. I mean, I don't know what I'm missing. That is a travesty. I'll try just defaulting to like, okay, if that didn't work, I guess just push whatever. I don't know. I don't... Okay. What does that look like? What on earth? It's bipartite, so you cannot be connected to your own color. It's... Well, maybe you can be connected to your own color if it's like your own color of a different depth. Whatever, I guess. I won't think about it too hard. Okay, I don't know what. I definitely have to go. Like the person I'm having a meeting with is running late, but I gotta get on first, I think. I'm kind of happy with that. Penguin migration. He's the current position of the penguin. Doesn't matter. That's interesting. I'm gonna double check after like what ELO this would have been. Thanks for watching.